Strathmore Energy Research Centre is an applied renewable energy lab that specializes on research, training, standard testings for renewable energy technologies, and also consultancies. As a part of infusing into the research and innovation goal of the university, we had started this partnership on the project called Energy Catalyst with the SolarisKit. And this project was aimed at promoting the use of solar water heating in Kenya by upscaling the various, the various technicians and engineers on solar water heating. So we are keen on giving them the skill set specifically for hot water for domestic use. Our vision and our goal is that as a center, we can become a center of excellence in training. And we have developed a curriculum. This is the first of its own, and we are hoping that we can build this more and engage the local regulators, and so that they can see how we can make this be a regular training. And upon the students being trained, they can then get even certifications from the regulators.
The solar hot water course, foundational course, will be useful and highly impactful to the Kenyans, given that the course trains engineers and technicians on best practices to design, install, and maintain hot water systems that absorb energy from solar energy. Now, this will have a significance given that it's a ready available source in the environment. It is cost effective, and it is energy efficient.
The way a solar hot water system works is quite simple. If you imagine if you stand outside, your skin actually absorbs sunlight and you can feel it getting very, very warm. That's essentially an absorption process. So your skin is absorbing energy and it's converting it into heat. What we do is we take that very simple concept and we engineer it into a solution that harnesses sunlight in a very efficient way to provide carbon-free hot water. So a solar hot water system basically consists of two main pieces of equipment. You have the solar collector, which is what's converting sunlight directly into heat. So it's taking that phenomena of absorbing sunlight and then transferring that energy to a fluid. So normally that's just water. And then what we do is we transfer that energy to essentially a hot water storage tank. And we heat up that tank over the course of the day using sunlight. So it's a very simple, it's a very effective, and it's a highly efficient process. So normally with a solar collector, it converts between 50 to 80% of the energy directly into heat. The water inside the storage tank will normally be heated, but that tank will also be insulated to minimize the heat losses from it. So imagine you heat up the tank on a nice sunny day like it is today. So at the end of the day, you have 50 to 60 degree water, but because the tank is insulated, it'll lose very little energy. So that hot water will still be there if you want to have a hot shower the following morning, for example. Obviously that's really important. Most people have showers at the start of the day or at the end of the day, but that morning shower is really important. So you have to store that heat from the solar hot water system in an insulated tank.
I was invited to attend this course on solar thermal, installation of solar thermal equipment, and I took interest. First of all, I want to thank the Strathmore University, SolarisKit, UK Innovate for sponsoring me among others. I was also, interested and also surprised to learn that we had participants from Rwanda and from Burundi. And so I found the course very insightful in terms of the technology that's available, especially with regard to the new type of solar collectors, which we refer to as prismatic type of solar collectors, which basically have been invented by SolarisKit. And I was also surprised to learn that the innovator, the person who invented the prismatic solar collectors, was in attendance and also contributed to the whole training program. The training covered other types of solar collectors that are also commonly available in the market here in Kenya. including the unglazed solar collectors, the flat plate collectors, the evacuated tube collectors. But what we found more interesting in this particular prismatic type of solar collectors is that they are able to passively track the sun throughout the day. And therefore, the orientation of the solar collector is not important because it's able to track it from every direction.
So I did like this course very much. The fact that the collectors are quite different from the usual collector that we've handled before. The prismatic collectors, bearing the fact that it doesn't matter the positioning of the sun, it really sounded quite good to me. And also the fact that it's light. Bearing in mind I'm a lady, for the other collectors I have to find people to help me lift them, but these collectors are quite light, so they are friendly to us women in engineering.
I'm very pleased for this training for the solar water heating by getting the more skills and the knowledge about the installation of prismatic solar collectors. We get more thing about to design the system from the Kenya. We get also to design the hot water to follow applicable for the domestic and industry in all the world.
This course is going to be quite impactful because I believe these collectors are, first, they are environmental friendly, they are quite sustainable, and I believe that they are going to be quite cheaper compared to other collectors. So personally, as an entrepreneur, because I have my own startup, I'm looking forward to doing a lot of business with it and impact the environment in helping reducing the carbon credits.